Of the 153 Chapter 5 test, sample test. All right, we have this. And so now if it was log and not a 2 in front of here, we could just set the arguments equal. So we have to know what to do with this 2, and the 2 goes up as a power. So we get log of 2x quantity squared equals log of 7x minus 3. And so they're both single logs on each side, so then I can drop the logs, and I get 2x quantity squared would be 4x squared, the 2 squared and the x, equals 7x minus 3. And since I've got a quadratic, I'll get it equal to 0, and I get 4x squared, subtract 7x from both sides, minus 7x, add 3 to both sides. Now I have a quadratic that I can either factor or use the quadratic formula. If I factor, I believe this factors, let's see, I got to get 7. I could do 2x and 2x or 4x and 1x. I think I'm going to need 4x and 1x. And if I put a 3 here, I'm going to get 3x. And if I put the 1 here, for 3 times 1 is 3, I'll get 4x and 3x. If they're both minus, I'll get negative 7x. So I set these equal to 0, and I get 4x minus 3 equals 0, which means x equals, add 3, divide by 4, 3/4. Or I set x minus 1 equal to 0, and I get x equals 1. Now, when you're doing logs, you always need to check your answers. So I'm going to check my answers here. Let's start with the easy one, 1. So I'll go over here and say I have 2 log, 2 times 1 is 2, equals log, 7 times 1 is 7, minus 3. So that's 4, and the 2 goes up, and so this is log 4 equals log 4, so it does check. The other thing I just need to make sure, it should, if I haven't made any mistakes here, it should work if I just check and make sure it doesn't make this be negative or this be negative, which it didn't. Now let's check the 3/4. So I'd have, I'll do that check. Oh, I'll do it here too. So I'd have 2 log of 2 times 3/4 is 6/4, or 3/2, equals log 7 times 3/4. 7 times 3/4, that's 21/4, minus 3. Well, 3 is 12/4. So 12/4 from 21/4 is 9/4. And the 2 could go up and make this be log of this squared. And 3 squared is 9, and 2 squared is 4, and so they do equal each other. And notice neither argument was negative, so they both should work. So our answers are those, and we did the check. Real important that I see the check on these, or I will have to can't give you full credit. Now D, this would be nice if we could just get this into being the same base on all these. And we talked about that early on in these logs. And so you can pick any base you want. I'll do base 10 because you tend to seem to like that better. So I'm going to go 7 is 10 to the log 7 times 3 is 10 to the log 3, and that is to the x plus 2. Equals, to make 5 have a base 10 would be 10 to the log base of log of 5 in base 10. And that is to the x. Now, when I have to multiply, I add the powers. And when I got a power to a power, I got to multiply. So this side is going to change to 10 to a messy thing here. And this side is going to be changed to a little bit messy. It's going to be x times the log of 5. That's not log of 5x, so be careful on that. And I got to take log 7, and since I'm multiplying, I add the powers plus, and then this is times these two, so it's going to be log 3 times the x, so I'll write it as x log 3 so that it doesn't look like log of 3x. And then I got to take log 3 times the 2, which I'll write as 2 log 3. Now, since they both have the same bases, the powers must be equal. So I have log of 7 plus x log of 3 plus 2 log 3 equals x log 5. Now, to be able to solve for x's, I want all the x's on the same side, so I'm going to move these over here by subtracting x log 3 from both sides, and I'll have log of 7 plus, and I'm going to put the 2 up as a power, log 9 equals x log 5 minus x log 3. And if I'm trying to solve for x, I can factor it out of these two and write this as x log of 5 minus log of 3. But when you're subtracting, that becomes log of 5 divided by 3. The log of a quotient is the difference in the logs. And both of those were by x, so that's why it's there. Equals, and these are added, so that's the log 7 and 9. If you're adding, that's multiplication, so that's 63. And so now I get x to be, dividing both sides by this, I get log 63 divided by log of 5 divided by 3. Now, that's not the log of a quotient. It's the quotient of logs. And so you can't split this up into subtraction or anything like that. So that's the way you have to leave your answer unless you go to a decimal. But I like exact values. Now, you could have gone to decimals here and then factored out the x and figured out how many x's you got and got a decimal here and divided the decimals, and you would have got the same as this value would be. Okay, E. So now we have log base 3, log base 3. So let's get it to a single one, and they're added, so that means we're going to multiply. So it's going to be log base 3 of x plus 1 times x plus 6. And it's the log of all of that equals 2. So now I have my unknown is in here, and when it's in here, we can write this as a power equation. 3 to the 2 equals all of this. 3 squared equals x plus 1 times x plus 6. Well, 3 squared is 9, and since it's not equal to 0, I can't set these equal to 0, so I'm going to multiply these together and get x squared plus 6x plus 1x plus 6. Subtract 9 from both sides, and I'm going to get 0 equals x squared plus 7x minus 3 when I subtract 9. And then I'll try to factor, and let's see, will that factor? That would be x and x. And I only can do 3 and 1, and that's going to be 1, and 3 is not 7, so factoring won't work, so I'll go to the quadratic formula. -7 plus or minus the square root of 7 squared is 49, minus times plus times a minus is going to be plus. 4 times 1 is 4, times 3 is 12, over 2a, and that's going to be 2, and all of it. So that's what x is going to be, and 49 plus 12 is 51, 61, and that's not a nice thing. So our answers are -7 plus the square root of 61 over 2, or -7 minus square root of 61 over 2. And that's more negative than 7. And negative cut in half, that's going to be like, let's see, 61 is close to 8. So -7 minus 7 is at least -14, divided by 2 minus 4, 7. -7 plus 1 is negative. That can't happen, and can't happen there. So this answer has to be tossed out. And this one might have to be tossed out. So I'm doing this check thing. Now, -7 plus a little bit more than 7, this will be a plus answer. Because this is, if this was square root of 49, this would be 0. But this is bigger than that, so it's -7 plus something bigger than 7. So this is going to be positive, divided by 2. This is going to be a positive number. Positive number plus 1 is positive, so that's okay. And also here would be okay. So this answer will work, and so we get one answer. This one doesn't work. And that's how to, that one. Okay, last page. Assume that there is a radioactive isotope that decays according to this equation, where A0 is the initial amount and T is in years, it's the time. Determine K if 5 grams, so that's the initial amounts, decays to 2 grams in 12 years. So the amount after some time is equal to the initial amount, 5, e to the kt. And it said in 12 years, so we're going to put 12 in for the t, and the amount left is 2 grams, and so I have to solve for k. Now, k will be the same for all problems dealing with this isotope. That doesn't change. The starting amount could. So I get the equation 2 equals 5e to the k times 12, so 12k. Now to solve for k, I have to divide out this first, so I'm going to divide by 5, so I get 2/5 equals e to the 12k, and since I need the power, I'm going to rewrite this as a log. So this says log is, the base is e, so it's going to be ln of 2/5 equals 12k. E to the 12k is 2/5. So always the base to this power is this. The power's over here. So that matches this. And I can find the ln of 2/5. Ln of 2 divided by 5 is -0.916 blah 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 equals 12k. So k is going to be that divided by 12. So I get k to be negative 0.076. That's close enough. So now I've determined the K. So my model will look like the amount after some time will be the starting amount, if I start with a different amount, but it's still, if it's the same isotope, it'll be negative 0.076 times however many years. So it says in B, if you started with 15 grams, so I'm going to put 15 here, how much will still be radioactive after 20 years? And the amount left after some time is equal to the amount you start with, e to this, we figured out the K now, negative 0.076 times 20 years. So now I just have to put that into my calculator. So get over here so you can see it. So I'm going to type in 15 e to the negative 0.076 times 20 close parenthesis, and I get 3.28 grams. Because this was 15 grams, and so we're talking about in grams. In how many years will 20% be still radioactive? Okay, so let's make this easy. Now I could figure out, I could put 15 here and then put 20% of it here and then solve for the T, but if I want 20% of whatever I start with left, this has to be 20% in decimal, so 0.2 is what 20% is, and e to the negative 0.076 t. And I want to know how many years this would take for this to turn into 20%. So I got to solve this. Well, since I need the power, I'm going to rewrite this as a log. So this is base e, so it's ln base e of 0.2 equals 0.076 negative t. So then I divide by negative 0.076. And these cancel, and I get t to be ln 0.2 divided by negative 0.076, and I get 21 years. .1 years. And finally, what is the half-life? Well, that's how long does it take to get to be half of what it was. So I just put 0.5 in here, and equals e to the negative 0.076 t. So using the same stuff here, it's going to be ln 0.5 divided by negative 0.076 equals the t. And that, so I just got to do the same thing I had before, except with a 0.5 there. And that's 9.12 years for it to be half of what it was. Okay, the final equation. And then I'll answer my door. So we got to solve this one. It says the amount left after you start with, and this is compounded monthly. So this is different than compounded continuously that we talked about in class. So the how much is in the account after 10 years. So A0 is how much I started. So $600. And then I have 1 plus R is the interest rate, which is 4%, but I have to do it in decimal. So I have 0.04 divided by N is how many times I'm compounding it in a year. And if I'm doing it monthly, I'm doing it 12 times in the year. do 12 times the t, and after 10 years, that's 10. So that's going to be how much I have after 10 years. So I just got to type that in. That's 600 parenthesis 1 plus 0.04 divided by 12, close parenthesis, to the open parenthesis. Now it's really important to put parentheses on the power here. 12 times 10, close parenthesis, and I would have $894.50, rounding it off correctly. Okay, and then let's see, B, how long would it take for the balance to grow to 1,000? So I'm going to put 1,000 as my final balance, equals 600 times 1 plus 0.04 divided by 12. That's all staying the same. 12 times t. So I'll divide by the 600, so I get 10/6, or 5/3 when I divide by 600. That's reducing it. 1 plus 0.04 over 12 to the 12t. So now this is my base. So what is that base? So I got 1 plus 0.404 divided by 12 is that. So now if I write this as a log equation, because I want the power, it's going to be log with this base 1.00333, that's probably enough decimal places, of 5/3 equals 12t. So I got to figure this out and then divide it by 12. To figure that out, I have a log that's not in base 10, so I can do log of 5 divided by 3 divided by log of the base, and that was my last answer. So now I'm going to get a real accurate reading here. That's what this side will be. And then I divide that by 12, and I get 12.79 years. And how long for it to double? That will be when this is equal to 2. So I now, instead of trying to get this to equal 5/3, I want it to be 2, so I'll just put a 2 there. So I'm going to have exactly the same thing. So I'm going to do what I did before here. I'm going to change the 5/3 to 2. Yep. Divided by, I have to put in 1.00333. Get that answer and then divide by 12, and I get 17.36 years.